Kronos for manufacturing, workforce management, something that Kronos pioneered 30 years ago. From our beginning with time clock and payroll automation, we've evolved to providing state-of-the-art solutions that can help you manage some of the most important workforce-related functions within your organization. We provide these, and you can see these over at the booth, in an easy-to-own solution, such as for your time and labor, time and attendance, HR payroll, absence management, and shop floor management. So if you still have time yet today, stop over at booth 28 and you have an opportunity, meet with Matt. He's one of our pre-sales consultants. He can take you through some of the solutions and answer any of the questions you may have. Right now, Josh, introduce them to the speakers, please.
Good afternoon. I'm Josh Cable. I'm a senior editor for Industry Week, and we appreciate you sticking with us for the 4 o'clock session, considerations for lean material flow, success at Ford. And thanks again to our sponsor, Kronos. Before I introduce our speakers, we ask that you just turn off your cell phones or at least put them on mute. I'm sure you know the drill by now. And also, as with all the other sessions, there will be an opportunity for questions after the presentation. Our speakers this afternoon are Larry Tyler and Larry McAdam. Larry Tyler is co-founder and principal of Kinetic Technologies, and for the last 7 years has served in a number of leadership capacities, the most recent being Vice President of Sales and Marketing, helping customers implement lean material flow systems in their plants and warehouses. He has 28 years of prior experience with the Lincoln Electric Company and its largest subsidiary Lincoln Canada, where he led an international program to implement operational cost reductions in plants in North America and Europe. He holds a BSc from Cleveland State University, Fenn College of Engineering, that's at Cleveland State, and an EMBA from Case Western Reserve, also here in Cleveland. Larry McAdam is Lean Material Flow Manager at Ford Motor Company, and he received his BSc from SUNY at Buffalo, New York. That's the State University of New York, and has been the packaging material flow engineer at Ford Motor Company automatic transmission operations for the past 15 years. He has prior experience in material handling at the GM Powertrain Division and has worked on various packaging design systems through Chrysler Corporation during the original launch of the Jeep Grand Cherokee. Please help me welcome Larry and Larry to the podium.
Okay, thanks for everybody coming to something like this, because I can't believe I was the only one that wasn't interested in this. So, as far as material flow plans and stuff go, we were kind of curious, Larry and I were wondering how many people are working on a plan or have a plan already in place as far as leaning and going to away from the traditional high-low venue of, got one back there, okay. This particular material flow plan was for Livonia plant in Livonia, Michigan. It was for the 6R transmission, which is a 6-speed, read 4Ds, 6-speed rear-wheel drive transmission, currently in like Expeditions, pretty much any of the larger heavy-duty rear-wheel drive vehicles. We have a more heavy-duty one that goes in 250s and 350s, and that's made in Sharonville. Did you have any more questions before we want to get started? Okay. All right. What I thought we'd do is kind of go through this a little bit quickly on the presentation, then give you guys more chance for questions, if that's okay. It's not terribly involved. I hope maybe you've read some of this or looked through some of it before, and then it'll make it easier just to go through the question period. Okay, in looking through this, you can see that, especially in the center body of this, at Ford, we don't do anything alone. There was a whale of a team involved in all of this. And you'll see that from some of the documentation and stuff that is shown further on here, some of the forms and different things we use. In smaller companies, different companies, you don't have the head count to do it the way we did it. So you'll feel free to adapt anything as you certainly can. But this was a team from a lot of different aspects that made this thing work. Again, more on the engineering and the team between the ergonomic and the SMF teams, and I'll try to explain some of the Ford lingo here. The MP&L are the manufacturing, planning, and logistics people. I interface with them a lot. They're the ones on the floor actually making it move around, and the trucking between plants or between suppliers to our plants. And then, of course, ergonomics was the next biggest thing that fell into all that, as well as personal safety for the people. This outlines some of the scope. When we started figuring out what we were going to do for this program, we had a clean slate when we were building this new line for 6R. We wanted to get away from high-lows. We wanted to get away from large displays of the stock and trying to head towards a lean environment. So from that, one of the key things here was that we started from a the line-side back material handling system and trying to put everything in the strike zone so that the worker or the tech on the line actually making products for you, that's what they did most of. We took away as many applications or problems or issues associated with their workstation. Workstation design was a big factor over and above what we did as far as actually moving the stock. Again, the teams and the people that were involved in this, the FPS, the Ford Production System, safety and ergo, packaging, storage, and the transportation. A lot of these are various aspects of MP&L, but it also tied in with mechanical engineering, where we take responsibility for new programs that are presented to a plant. We design it all out and then start involving the plant people in the application and instilling it onto their floor. And these were some of the aspects of how we wanted to control it, were the material flow routes and frequencies, how often we did bring stock to the line. 2 hours max, 1 hour minimum was our desire to have that to minimize how much space was taken at the line. Suppliers were in contact with us all the time, or we were in contact with them, trying to set up an issue or a situation where what they sent us is what we really want in the 7 R's, the right size, in the right place, the right time, the right quantity. And then as far as the transportation, the MP&L side really worked closely with setting up the windows, how long a truck could be at our plant, when they would be at our plant, because we did not have a large warehouse facility set up to store stock. We had set up card markets and call markets, and the call market was the smallest we'd ever had as far as trying to service a line. So everything was set up on demand, a pull system that's just in time. The suppliers worked with our packaging engineers working on the PFEP. As they populated the information, we put it into a plan for every part. It was documented to everybody. You had the max sizes, the tears, the grosses, right down to if it was a tote, how much stock was in the tote, the size, the weight, everything that we needed to know so that we could actually handle this thing safely and easily. The dunnage was all returnable, and it was detailed again in the PFEP. And the packaging, all that information was started from the Form 150, kind of a sacred form we have there now. We used to have a Form 1120, and everybody in their world had their own copy of it. The current Form 150 is standard across the line. There is one, and that's it. So we've been able to standardize on a few more things for ourselves. Again, looking at what the operator touched, the tote weight was 35 pounds or less, and you had your strike zone. We tried to minimize any indirect labor that was involved so that not many people had to touch this thing, because the more times you touch it, the more things go wrong. The Ford Production System, the work groups We had many reports of how to track things, and we track things a lot. 5S is how to clean up an area and set it up for yourself. There's a whole detail of that kind of information. And then we had a 1295 form that when you buy something, you have to also put, if it's going to be used on the floor, you have to have repairs in stores, spare parts, and who's going to repair it. Everything is documented before you bring it in. Or at least that's the entire intent. As far as planning, we did a lot of planning, simulated a lot of things, and we had concern decks and issue decks that you close them off as they were done. Kind of the old Visine chart, the red, yellow, greens, tracking things. And then something near and dear to more supervisors at Ford are the 8-panel charts that tracked everything down to how much dirt was swept up under stuff, I think. And again, as I say, when we track stuff, we tracked everything. We had charts for it. You can read through these at your leisure. But it just did show that whenever we were focused on something, timing was everything for a lot of people on this, that we had to bring it in on time, and it was developed to follow that. As I mentioned before on the PFAP, we tracked for the part numbers, who the supplier was, the part weight, length, width, height, all that kind of good stuff, density, unit pack, because that followed again into our min-max levels, 2 hours max line side, 1 hour minimum, whether it was a call or a card part. And the call parts are obviously that the density sucks. We've had parts as small as 45 parts per unit load, like torque converters or something like that. So not only they're clumsy, the density was low. And then for that, for both the call and the cart, we had a line side address where everybody could keep track of where they were going to. Another one of our charts, and you can see that we've got it 10%, 20% across 100% of your completion, whether it's yellow or red or green on the left side. And it was also tracked by date and responsibility, who was working on it, what was the latest response. And when you were in these meetings, if you didn't like a response, you were certainly entitled to challenge it, and because it was probably affecting timing that you were on, something you were working at. So we wanted to make sure that this was resolved and everybody had input. If you didn't attend the meetings, it was your own fault, but it was all here for everybody to follow up on. We did have a few reds, and even showed up on my line, by the darn it. But when we close things out, you keep the history of that so you know how they were resolved in case it comes back again, or you run into that issue again on your next program. Part of your lessons learned, you might as well keep the action decks and all the issue information there. Was it resolved in a timely fashion or not? So you know whether, okay, that's not the solution we want next time around. I mean, this, some of the tasks that we had for the CMMS, which is one of our main computer systems, and the part tryouts, the PPAP parts, that if you're a supplier to Ford, you're familiar, or pretty much anywhere you're familiar with what that is. Down further where we did the min-max floats and the tugger analysis, we simulated everything that was going to take care of line side address, right out to where the truck was when it came in on the property, what dock it went to, when it would be there, when it wouldn't be there, and what market it went to, call or card, and how it got there. And then going out to the line also was routes, and then coming back. We did a lot with starting with the line side address, so we looked at, and I'll use the brand name, Creform racks, how you displayed the card parts mainly, whether we needed lift tables, and definitely whether we needed carts, how we were transporting it. This was one of our supplier logs of how we tracked and who was doing what. Did black out some of the names for things, but we did follow up on everything as to resolutions. And because that matched all your pre-production builds. If you're going to do a 1 off or a 50 off on a line, you wanted to make sure you had enough parts to make all 50 transmissions. There's only 235 parts basically in a transmission, so only 1 or 2 could screw you up. This was a note that went out to all the suppliers supplying PPAP parts. So this was the process and procedure for setting that up, tracking it, following it. Again, as we said, there were a number of people of teams and lots of team members. You were invited to every meeting. If you didn't attend every one, that was fine. Send a representative. Another big thing that when we got into carts that would be used for call parts was the ergonomic push-pull studies. There's 50 pounds initial force to get one moving, 35 pounds sustained on a load approximately 15 to 1,800 pounds. When we decided to go to carts as a transportation system rather than forking everything, and that was one of the criteria, or some of the criteria that went into selecting a supplier, because they had to meet that and a number of other criteria that we'll get to a little bit further down the road. These are just some of the roles we did, but everybody participated, whether you went to the millwrights on setting up and building the creeform, the material flow meetings, tracking the action decks, and then each person, or there was a subject matter expert from each process. Down at the UAW ergonomic reps, we had our divisional ergonomic reps. Everybody was involved in how they were going to track and document the best-in-class practices. And this was some of the another chart we have for who does what on that. And some of this seems awful basic, but if you don't assign it to somebody, somebody's going to assume that somebody else is doing it because they don't want to put their head count into it, and they're expecting you to take care of it for them. So we went through right down to what the high-low driver does, what the tug driver does, what the responsibility of the operator and techs are at their line side display when they get a cart. Part of the main reason for getting rid of the high-lows was that we didn't have to wait for a high-low to move stock. So telling the production operator that they have to push the cart off the lift assist or out of their work area and grab the next one to keep themselves going was, they didn't take it well the first time around. Now, all the call parts are stored near the production areas, and when they were received at point of view stocks, it did improve our overall flow. We tried to make sure that there was a dock near where we needed the material to be stored at, so it just decreased how many people touch it and how long. The 4-hour transmission is a current transmission we make that goes in, I think there was like 28 different varieties of this transmission. We're down to a few less now as the 6R takes over the market. And again, this was a 4-speed rear-wheel drive. We're making a 6-speed rear-wheel drive, which gives you better fuel economy, a little bit smoother shift action. But what we did here was relocate some of their markets to make the 6R market flow better. The particular spot down at the bottom where you see the front-wheel drive and components offices, I have a lot of people coming out of those and going in and out of those offices on a regular basis. So pedestrian safety was an important criteria here also. And that's one of the things we have to simulate to make sure that we don't intentionally hurt anybody along the way here. This is a little bit difficult to see, but anything that we needed for layouts, changes, how much space is required, it's all valuable space. You're not manufacturing something. So we had to track it and make sure that everybody was in agreement. Again, that was another set of meetings, but everybody came to the meetings and spoke their piece, and then we came to an agreement. The packaging meetings, this was mainly handled by the MP&L side, but they would fill in the Form 150. But then once we got the Form 150s filled out, we would go through this at our standard meetings with all the techs, material handling people themselves, and include more of the layout people also, just to make sure that everybody was in agreement with how it was going to be handled. Because again, you assume certain things and they don't always pan out that way. Some person's impression of something was different than what you would think would be obvious. packaging strategy was, one, to green everything as much as we could to get rid of expendable dunnage. We did it across the board. We had a designated packaging engineer that just worked on this program, and she did an admirable job of making sure that we got what we needed, but it was also something the supplier could live with. At Ford, it's supplier-owned returnable dunnage, and it's blended into the piece part price and amortized over a certain period of time. Internal dunnage, which was more my responsibility if it's in process, and we usually launch off of whatever the shipping dunnage was. If the part is still very similar, that we keep things standard. We'll use the tooling that the production people use from the supplier, and pay a royalty to actually use that tool if necessary, but we're buying it in the long run. Then the easiest thing in the world was you just stripe it a couple different colors, and it's acknowledged visual factory that it's a returnable in-plant dunnage. The pallets were standardized. We went to a 45-48 or a 32-30 pallet with seat belts. There's no banding, definitely no steel banding allowed anymore in a Ford plant. You can get it, but it's a special dispensation kind of thing to get it. Whenever possible, to minimize washing of the totes, we put a plastic bag liner in there, and if it was a VCI-treated bag to prevent rust, that was even better. But all of that would have been detailed in the Form 150. This was a station review form, a checklist that we used, and all the questions on this would be filled out for every station, of which you would probably have anywhere from 90 to 130 per line. But every station got one of these filled out so that everybody was in agreement. There were no mysteries, there were no assumptions. This was what it was or it was not. And again, more ways to track it. This is an example of our Form 150. You get actual pictures of the part, individual part weight, the container that's being used. If it's a standard container, it's got a TA number or an SP number or something like that. If there's any special or unique features about what's going to be involved in this packaging, it's all detailed on here. And down at the bottom, what you can't see is we had a spot for 6 specific people or job functions to sign off on this before it was accepted as fact. And, but all the information, even though it wasn't nailed down at this point, it was on the PFEP, so that we'd all track it. It would be just colored or indicated that this was something that was in development. Once it's fixed, and we've all agreed on it, it's tracked as under a different color or indication so that everybody does know that one, that's what we're getting. So again, on Wednesdays, we had a standing meeting for our line side reviews, which you'd seen the check form before. And that had to be signed off again by the 6 people that, or the 6 groups, a representative from each one, that this was what it was going to be and how it was going to be handled. And this is as detailed as it got. We had a small spot over in the in a crib, and we would actually set up the work pallet where the transmission was being assembled, how all the dunnage and the creform was built to display it to the operator, and everybody, including a lead tech for that section of the line, was involved in it and signed off on it. So we would make up our form of whatever we had to present everybody, so that we didn't create it while we were out there. You would put all the standing information on the form and then let everybody read through it, check it off one step at a time. Really important at this particular time was the ergo reps, be they divisional or union, just to make sure that it was in the strike zone, it met the long-term functions. You can do anything for a couple hours, but if you have to do it day in, day out, every day, you just want people to go home tired, maybe a little bit bored, not wiped out, not sore, not regretting that they got to come back in and do it all over again tomorrow. You hear a lot about fork-free infields or fork truck, fork-free, just the whole thing. Everybody thinks you can get away from running a plant without a fork truck. I don't know how you would ever do it. What we did here was we decided that the infield, which was the line side proximity, anywhere in the assembly area itself, we would try never to have a high-low there. If you did, it would be in a red zone. You should have a colored vest on so that it's a little bit easier to find you. There's no people just wandering through. It's a bit of a sacred area. If there's going to be a high-low there, if there's ever an accident between a pedestrian and a high-low, the high-low usually wins. So we just wanted to make sure that they were safe. When we did move something, which was the Tug Carts, that the minimum pushing or pulling force was 1,500 pounds at less than 50 pounds pressure initial. And then we looked at a whole different bunch of things because we hadn't had them before, was whether the hitches and the tongues and the brakes, everything, how do you use them, who uses it, what do they do with it when you park it. A number of other things came to light about how we would do it. My friend Scott and I were here testing a particular cart, and everything that we did was tested on the same piece of floor so that you know that it was flat. Later on in this, I believe there's still the how to do an ergonomic push-pull test. Everybody had to pass the same test. We had about 8 different vendors that sent us different carts and configurations of how to do it. And we managed to launch this program with only 3 different carts. This was one of them, which we call the lowboy. It's the only 4-wheeled cart of the lot. And as I mentioned before, this was the one that has the worst density. There's only 45 parts in a unit pack of this thing. It is, you can see there's a lift aid there for the operator so they can go closer to the floor to pick them up. In the inset, you'll see that there's a little bit better picture of the whole unit pack there. And believe it or not, this cart still at 4 wheels meets the 50 pounds or less initial push force. And we're encroaching very closely on 2,000 pounds of this unit load now. We went to small tug carts, small tugs to tug the carts. This is actually at a picture taken at a Cleveland plant, but our tugs are very similar. And they squared away or set them up on a 4-wheeled cart. The ones we use at Livonia, you'll see in a few more pictures, are 6-wheeled carts, which allow them really to turn within their own length. It gives you a lot more nimble effect when you're trying to move things around in a workstation because we don't really give them all that much room. The ergonomic process follows down through this flow chart. When we get down to the bottom line here, the verification, the workstation layout, and the creeform development is all when it's really hitting the floor. A lot of it's before that is the paperwork side of it. But it has to work, and everybody has to agree that it works. Here's a few more carts that we evaluated. And this is the checklist of that everyone went through. We'd given a specification, we'll see a little bit later here, of what we wanted in a cart and how we wanted it to perform. But these were ones that were existing at other plants, and we wanted to see how they used them and how they would work for us. This is the push force measurement. Again, it's over 10 feet, and you want to use the same spot on a regular basis so you get standard readings. We did find that it is possible to cheat on these things, so you have to be careful of yourself. You learn different ways of how to push a cart, and you have to get yourself back to, I can beat the system for a couple of times, but the person that's going to do this every day, all day long, you got to do it like they're going to do it. So again, we did, set up the process and the rules to follow on how to do these tests. The initial force is, of course, when you first go to move it, but we tried to make it as difficult as possible so that the worst case scenario was portrayed. We would turn the wheels 90 degrees out of alignment with a full load on it, give it a push, and the gauge we used for it did not have a large, it was probably about the size of a thumbtack where you actually touch the handle. So you were getting the worst possible chance at making this thing work or fail. And we also timed the travel so that you really had to do it so that you kept the person in cycle and within reason of their job expectations. The sustained force, once you got it moving, how much does it take to keep it going? Something that you really don't think of at this particular point is somebody's going to stop this thing. When you get 1,800 pounds of something moving, and you've got a 95-pound female at the low end of the height range, keeping control of this thing is a major factor. We wanted to make sure that it was something that they could plant at least 1 foot and slow it down or steer it and direct it. So even though, and that's part of why we went to the 6-wheeled cart, but it was something that was a consideration. You know, everybody could get something to move. You do eventually have to stop it safely. This was some of our criteria that we put on there was we wanted it to have 6 wheels because we found one that was very nimble with the 6-wheel design. We positioned it a little bit differently, so it was about a third back under the back end of the load. We wanted a rotating deck on the cart so that we didn't have to worry about rotating features to get the cart to move, because moving the cart takes more room than just moving the deck. We did want to be able to lock it at every 90 degrees. We wanted the tongue to fold up and get out of the way so it wasn't a great trip hazard, because they really do hurt your shins. We want to make it easier for the high-low driver. We put locating plates on the corners, gave them a larger deck than the pallet so that they had room to place it on there. And we had a floor lock. It's called here as a floor brake, but it's a floor lock. It'll keep the cart from wandering off if the floor is uneven or something like that. It's not something you could put on and stop a cart when the cart is moving. It will help, but you've now taken your foot off safe, smooth floor and put it somewhere where you have a good chance of picking up an injury. This was the particular tug that we ended up using at Livonia. Safety did ask that we had a screen on the back to protect the operators from anything coming off the carts if there was a sudden stop, and a bit of a head rack thing there to protect the operator's head if they're a little bit taller than the average. Now, these carts did require occasionally to be lifted. So we designed into the base of the cart a way of locating it to a lift table, and then we came up with a new lift table. As I mentioned, we had 3 different kinds of carts. The low boy we had, this is the larger, a 50-inch of the large carts. We also have a 40-inch deck, which took the 32, 30s, and anything in between that. The same lift table works for either of the 40 or 50-inch carts. We try to be as generic as possible on this program so that if we ever change something at a station or whatever happened, we didn't have a lot of, I don't have the right one. And this was one way we kind of ironed that out. They are air operated. They collapse down to about 7 inches in height. The carts we use are provided by, we buy them from K-Tec, but we worked with K-Tec and the lift table supplier to make sure that they interfaced well. There's leading tapered edges on the top deck of the lift table that mates up to some leading edges, tapered edges on the bottom side of the cart, so that makes it easier to locate the cart to the lift table when you need one. And that's as simple as how it is to dock it. You just push it on over there. Towards the left side of this picture, by the large hand, you'll see 2 posts sticking up. Those are where when you take the lid off the load, you've got a place to put the lid, so it's, again, with the pack, but it's not on the floor, it's not getting lost somewhere, it's not falling over in somebody's way. It stays with the whole unit pack. This was another idea we had, was that once we purchased the carts, you've got a lot of money tied up, or some money tied up in the carts themselves. This required a unique top to it for our main control valve bodies. We made a book rack cart that each one of these layers opens up. You'll be working at it from the other side, of course. You always work from the back end of the cart, not at the handle end. And then when you're done unloading that side or loading that side, you just rotate the thing around and you fill up the other side. But the nice thing was that this just bolts to the cart. Whenever this program goes away or changes enough where I can't use this top anymore, this top hat, I just unbolt it, either scrap it or rework it, put a different one on there. If not, I've got the cart back, which can be quite a savings there. This is some more requirements we had for the carts. that they had to be able to roll over the lift table and the ergonomic devices. And we even had built in a little device there that there's a switch on the lift table itself that the cart has to be fully onto it and make the switch before the unit can be lifted. And again, K-Tec worked with us on how to put that in there so it would handle all that kind of stuff. We wanted it to be welded. Everything had to be retained and contained within the cart itself. This time we were looking at 4 or 6 wheels, then we found the 6 wheel to be better, and that's what we went with across the board, with the exception of the lowboy cart. I think about the only change we made on this whole thing after we designed the carts was that we did stick with the 4-wheel or the 6-wheel cart. We only tugged them in 2s. That's the way it was simulated anyways. And all the other requirements we called out are pretty much the same. Now, Larry, at this point, if you want to interject anything, we had all these requirements, and then we drew on you guys to make sure that you could fulfill them. Like I say, we had 8 other suppliers that sent in carts and stuff like that, but this was the only one that made it all.
One of the things as engineers we were stuck with, and I'm going to share this with you because as potential lean material flow people, you're either going to get carts one of 3 ways. You're either going to buy them from someone like us, you're going to make them yourself, or you're going to go to a local fab shop. That typically is how it's done. And what we've learned is regardless of the method you choose, the keys that Larry has shown up here begin to show up. In other words, a cart is not a cart. And why are we spending so much time on this? Because this is lean material flow. Well, because this is where the rubber meets the road. When we're done, at the end of the day, this is the vehicle by which all your material is transferred. And it has to interface correctly with humans 7 days a week with abuse. So the biggest thing we found was most people made mistakes of assuming that I could get something from McMaster Carr or somewhere else and put my dunnage on and we'd be fine. Well, we learned, along with Larry and since then with thousands of customers and carts, that the design detail is really critical. Things like pinch points, things like rounded corners. Some of the carts you saw up there were first generation. We've since beveled off and cut corners. We've taken off edges where human beings find problems, and they do so very well. They're able to see things that we don't see. So we found also that the functionality of the cart was critical. Larry mentioned they have to have lift pockets. Well, people need to have those raised. Sometimes you're building on an elevated platform. Then it's the how far can that cart go up? But wait a minute, that means the lift has to be bigger. But wait a minute, that means the pocket exceeds the size of the cart. But wait a minute, that means the closed height is too big. So as engineers, we were constantly faced with the challenges of the domino effect. One change, thousands of things or hundreds of things begin to change. So the only thing we found and you will find as well as you get into these programs, is carefully select the criteria, as Larry did, functionality. What do you want to have happen? And then challenge the builder, whether it's yourself, whether it's us or whomever, to meet your functionality challenges. No compromises. This is what you want in that cart. And if it doesn't meet it, then keep looking till you find it. Because that's where the key is in this whole situation. The last thing you don't want to do is take a fork truck out of the environment and exchange one problem for another. You don't want to put a cart system in or have 15 different models of carts, which is not a good idea, and have problems trying to manage the fleet and also have human resource issues and so on. So maybe that's common sense, but it seems to reoccur over and over across the United States. The potentially I do myself, but I don't have a plan. So if I can impart anything, and that is, be careful on the front end.
Yeah, it's a good point. We learned an awful lot along this way. Keeping it in the work zone was a difficult thing. And then once you get a process up and running, the other thing that, as Larry mentioned, anytime you make a change, you really have to think through, what does this do me about this or that? The fact that we have very generic carts, they could go anywhere in the facility on that line, You have to check out at any of the unique stations, because it's still going to work there. Because the last thing you want to do is buy a cart that has to go to a specific station. I got it, the one with the low boy for the converters. I've run into a couple more where I got some oil pans and one or two other things, but at first you always try to go back to your most generic carts, because that's your best bang for your buck in the long run. This was some more of the criteria list that we went through, and again, like I say, I had 8 different people supplying these samples, and really only one made it by the time we were done. It passed enough of the stuff that we were good with, and we could change and make a few changes that one and bring it right in where we needed, in addition to cost. We did check a lot of other plants because we were trying to do something best in class. Some of the stuff pertains to directly material handling. The picnic table probably doesn't. One other thing we did do to prove everything out before we spent a lot of money was to simulate it. And you can save an awful lot of money doing some what-ifing here. And it's certainly worth it. That's one of the first things when I do studies now, for putting money in for new programs. That's the first thing. I'm going to check and recheck a number of things. One, to make sure that I can get everything around and get it back. And 2, that I don't hurt anybody. I don't run into any pedestrians or keep pedestrians away from my working equipment. But they can tell you an awful lot of things. You know, we're probably simulating your work cells, where you're actually machining or doing not just the assembly line work. It's worth it. It's money well spent. When we did our card parts, we started out with, and we went to the quad steer style carts. They've decided to go away from those, but you do things for reasons that make sense. When they could propose a reason to make a change, again, you convene all the teams, you go back through it. We made this thing on information. What changed? Was it really worth it to make the change again? So you can make changes, just think them through. When we did the simulation, we modeled a lot of things here. How people were getting in, getting out, could the thing make the turn in that area? How long does it take? We timed and checked it a number of times. We had 2 routes that ended up being on here. The lifting actions for an operator that was going out and delivering parts on the card part route. Total amount of weight that this person had to lift on a trip, and how many totes they handled. We have an amount that we didn't want to overhit. There's an algorithm that works out in one of our other computer systems that checks this. So the simulation, knowing this, we could plug in that detail, and they could tell us whenever we were over, and then we could make adaptations as we needed to go along. Again, the weight, it's important for one thing is to see how much you physically work a person loading and unloading those totes. And 2, does it balance out again on your PFEP that was actually what you were supposed to have in there for all those weights, because we know what the weight of each tote was supposed to be. Just a way to back check a few things. How long it took. By the time you add up all those little times that are put into the simulation and stuff, you can find out, do they have the time to make the 1-hour loop and then rebuild their load. So again, we back checked everything. And then the pedestrian safety, we even did simulations on that. We knew when people came to work, when they left, where they went, where they took their breaks, where they went to the bathroom, typically whether it was mass relief or individuals, when and where. And again, my little corner down there at the bottom left was a potential hotspot for us, and we found ways to either time the pedestrians or time the loads so that it wasn't quite the issue that it was before, and we got a green on all of that from the plant safety office. To date, we really haven't had anybody injured due to tug interface like we used to with high-lows. Some of the things about the pedestrian safety, though, was we relocated some aisles. We put barriers in front of some doors so people couldn't just walk out into aisles. Cribbing around some of the markets so that parts couldn't be knocked over inside by a high-low movement. And put up mirrors just so people could see around some corners. The synchronous material flow, we had a smart card system that when people pulled things or there was a button they could push that when they needed a call part. and the card parts were part of the, we started out with a card system, and they eventually went to, when they got to the card, you hit the button, and then the guy could start building his load immediately, so it just smoothed a few things out. Found out a few more things here. It's like even in the part description where we took a picture of every part, and in the background there, the little checkerboard is actually a 1-inch square black and white dot. When you take a photograph of the part and then that's behind there, everybody gets a good way to measure the part very quickly. You have a good idea of length and width. Because the people that have worked on the lines, you know about how big something needs to be, whether it's going to fit in your workstation or not. But here was when we did track who was moving something, when and where, and the frequency, if it was going to be a problem, that we could smooth some of these things out. The value stream mapping process, again, was built partly into the simulation, and a little bit standing alone was just how much do we need at any given point when. And I'm not an expert on value stream mapping, so I'll just say that we included it in there, and we had a very good representative to help keep us clean on that front. The benefits were that when we stole any good idea we could find, whether it was at a Ford plant or somewhere else, the suppliers interfaced with us. They learned how we were doing things and kind of understood more of the why, and they stole a few of our ideas for themselves, which was great. It was a win-win situation all the way around that. The bill of material reviews with the STA people on the purchasing side helped a little bit. And the line side reviews were one of the big key things for us. Selecting carts was a real step forward for us because we've done that on every program since. They've all been modeled after this one, and take our lessons learned and make sure that we're stepping forward. Again, if we find an issue that keeps cropping up, we go back to our issue deck, see how was it resolved and why, and try to do better next time. And that pretty much wraps up what I've got to give you. If you've got any questions now, we can go into those. Yes, sir.
What happens if your supplier changes the dimensions without your knowledge?
They get QR'd, which is a pretty good black mark on there. Certainly we're not going to stop a line by refusing to take the stock, but we're going to drag them in and make life miserable for them. You have an opportunity and a forum to make a change if you need to make one. Let us know. Any communications not shared is useless. So if you got a problem, you got an issue, tell us, because we're going to tell you if we need to make a change. It might not be pretty, it might not be pleasant, but we'll do it.
What precipitated the need for this particular project? And I apologize if you covered that at the beginning. I walked in just a little bit late.
It was a new line, and you can always do everything the way you've always been doing it, but we wanted to get a little bit better results as far as making our plants neater and cleaner. We had a chance at a green slate to make some improvements, so we thought we'd take what would it take to make these improvements and what would be the benefits. And again, we went through some of that with our simulations before we bought or did anything. We had to convince our management this was a better way of doing business. It did add incremental headcount, I'll grant you that. It's not cheap from that particular aspect, but it is safer. The material is available to the operators a lot easier. They can make their own changes, especially if you have mixed parts at a station. If you've got an A and a B or something like that, they can actually control some of their own futures. Yes, sir.
Larry, I speak Ford, so I'll ask my question and then I'll translate. By the way, congratulations on not taking the government money, so that's my paid political announcement.
Thank you.
When you went about this, and I know based on that question and what you showed us, that there were implications or improvements based on ergonomics, safety. I mean, I saw a lot of that. I'm assuming the smart card system was a Kanban type of system, correct?
Yes,
Okay.
yes it was.
So then when you had CMMS, you involved your MP&L department, obviously, right? So that's material control department. CMMS is your material handling or your material control system, right?
Right.
Did you have to reconfigure a lot of the things? Because it looks like you got to go back through on all your lot sizes and everything like that. Was that a constraint in going to that? Because where I'm at with our company, sometimes our systems seem to constrain us on the decision to go to a Kanban type system. And was that a constraint for you?
No, it wasn't, because it was a clean slate. We were starting a new line. If you're trying to reconfigure a line, I can see where you would have that problem. But you have to make the leap. At some particular point, something is better than what you were doing. And the best way is, again, go through, simulate it, show them where the advantages are. It did help us lean down the markets, because one, we didn't have enough space to store everything all the time anyways. So we worked line side back to the market. Okay, this is how much we can hold and control in the system. That helped drive our business case to our management, say, okay, this is what we need to do, and this is how we need to do it. And we can show them that it was either working at another facility or that we simulated and it will work on our facility. We just need to implement it.
How long did this whole process take place?
Our launch curves were generous back then. Probably took about 1.5 years overall. A lot of it, probably the first 4 to 5 months, were just paperwork. How are we going to do it? And go out and do a lot of field reviews at different places. Thank God we had a lot of places other than Ford that we returned the favor. We got pigeonholed through some suppliers. Okay, we'd like to get invited over here. We'll reciprocate. And we actually worked it out. It did happen. We went to other Ford facilities, checked out. Again, we were looking for what's best in class, what'll work at our place. And some of them were a stretch. There were a lot of people that weren't convinced, even when we launched, that it would work. And a couple minor tweaks and changes here and there. Nothing's perfect when you first throw it down, but it did work out, and we worked with the process. It was a bit, kind of iterative. We worked it through. The worst thing you can do is think you're infallible. I'm not waiting to make my first mistake, and I can't remember the date when it went by, but just work with it. But if you can show your management that, like I say, you got to make a step, plan it out.
Is this process part of your supplier selection? And if a supplier isn't capable of providing this kind of service, do they work through 3PLs? Do they work through, how do they handle that?
As far as the material handling suppliers, is like the carts and that kind of equipment? Oh, that is totally through purchasing. I have nothing there. Actually, MP&L will put that supplier's name on the list on the PFEP when it becomes known, and then they also give him a contact, and then we start the development from there. If they've been a Ford supplier in the past, it makes it easier. If they haven't, then we have to invite them in and say, okay, this is what we're doing. This is how we normally do things. And we usually run into a lot of suppliers where they don't have the material handling people that we do, obviously. In a supplier, I've worked at suppliers early on in my life, and you wear a lot more hats. But it was something where we invite them in and show them what we're doing, how we plan on doing it, and if we can, with our STA people, take it back to their place and see how it could be a benefit to them. But no, the purchasing people pick all who the suppliers are for whatever their criteria is. We must have done a good job.